This video is on section 4.4, assignment number 27. This is a second video on expanding logarithms. I just feel like we might need to work on several more examples. If you understand, that's fine. If you don't, you might want to really pay attention to this, and let's hear it again. I have one logarithm, and I want to write it as multiple logarithms. Now, I notice that x, y, and z are multiplied, and you remember that with logarithms, with the properties of logarithms, we associate multiplication with addition. So the first thing I'm going to do is take log base a of x cubed, which is the first part of my argument, add it to log base a of y squared, the second part of my argument, plus log base a of z. Notice I use the same log and base for each. Now, I had another property that said if your logarithm has an exponent, you're going to bring it in front as a multiplier. So this would be 3 log base a of x plus 2 log base a of y plus log base a of z. And that would be our final answer. Number 2 is another repeat. Here you see division, but what I want you to notice is that within this division, numerators are being multiplied and denominators are being multiplied. So I think I'm going to first separate this. Another thing to notice, it doesn't have a base, so my base is understood to be 10. I don't have to write that. I think I'll take log 5a, which is my numerator, and subtract, because this division line says to subtract, log 4b squared. Now, since I do have a product, that needs to be associated with multiplication, so that's going to be log 5 plus log a minus, now I have another multiplication, so this will be log 4 plus log b squared. I don't have anything else to simplify with the first two terms, so I'll write them down. But now here, this negative is going to distribute into both of these terms. So I'll have minus log 4 minus, and also this exponent 2 is going to come down as a coefficient, 2 log b. And that would be my final answer. Okay. I want us to work two more that have radicals in them. Sometimes simplifying those can be just a little tricky, so we're going to work another of those. I have log c cube root y cubed z squared x to the 4th. Alright, I think first thing I'll do is to get rid of the radical sign, so I'll have y cubed z squared x to the 4th, all raised to the 1/3 power. The 1/3 takes the place of the cube root. Now you know that if your exponent has an exponent, each of these will be multiplied. So that's going to give me log base c of y. 3 times 1/3 would be 3/3. 2 times 1/3 would be 2/3. 4 times 1/3 would be 4/3, and those are my new exponents. Okay, I do notice that I have another little simplification I could do, because 3 over 3 is actually equal to 1. So just y, z to the 2/3 over x to the 4/3. Now we can get down to what we started out to do, and that's to change these to multiple logs. Here's division, but within the division I have multiplication in the numerator. So I'll have log base c of y z to the 2/3 minus, there's my division line, log base c of x to the 4/3. But now remember, this is being multiplied, so I'm going to add. That would be log base c of y plus log base c of z, and at the same time, if you want to bring that 2/3 over, it would go in front as a coefficient, minus log base c of x, and again bring that over as a coefficient, multiplied by 4/3. And there'll be our answer. Each one of the radicals is just a little different depending on how you can reduce it. The first thing I notice in problem 4 is that I have a's and I have b's, so I think I can simplify that a little to begin with. When you divide, you subtract, so a to the 6 over a squared would be a to the 4th. B to the 8th over b to the 5th would subtract and be b to the 3rd. And now that looks a little simpler already. So I have log of, let's see, a to the 4th, b to the 3rd as a square root, so that would be 1/2 power. Now let's multiply exponents together. That will be log a to the 4 over 2, b to the 3 over 2, or log 4 over 2 is 2, and b to the 3 over 2. I need to go back, and if you'll notice that was a log base a. I need to put that base in here, and here, and here. Now here's where we're going to say that we have multiplication, so we need to simplify or separate by addition. Log base a of a squared plus log base b to the 3/2. Now remember our lesson before, such that we have a base and an argument that's the same, a and a. That's just going to give us the 2 as a simplified result, plus bring this exponent over. That would be 3 over 2 times log base a of b. That one's simplified a little differently, and you're going to have to watch all these rules that we know are going to have to be used. And that's just a review of the previous video.